So what I've been showing you is this steel block that I got from the welding shop. This was just a big chunk of steel that I found over in their saw area, and I asked if I could have it. They give it to me. This is a piece that I've been doing. Been trying to go through the programming and continuing learning how to come over here, like I said before, and just get some practice in. And so far it's working out real well. So it was sort of like a trapezial shaped piece. If you look at the screen here and see the green outline, of course that's our cut pattern there. You can see where one side sort of had an angle on it. So it was a pretty good practice session. We actually made use of our Adaptix vise for this right here to come in on that angle side. We got the angle to this side here. This finger right here, I've got stuck in there to prevent the piece from going out. So it's like working as a work stop there. And I just finished the first depth of 1 inch, and then we're gonna go down another inch and just repeat our cuts. And so far, man, it's been working really good. I made a couple of tweaks to the program for that particular cutter. That is this 3/4 inch Titan carbide end mill here. And I started off pretty light on that, so I stopped it. And now we are running, let me shut that because the coolant's coming out. So I've got it set to 1273 RPM, and the feed rate, I've got it actually, let me see, I wrote it down here. So I've got the feed rate set to 25.5 inches a minute with a 25 thousandths radial depth of cut there. And it's working really well. It's actually nice and smooth. You see the chips down there look nice. I wasn't sure how the cutter was going to react because that is kind of a longer general purpose end mill. So now it's going to finish going down. I just brought the feed hold all the way down to 0, and it'll go down to 2 inches now and do that same exact cut just to clean that up. All right, so now we're continuing on with our second cut. This is our final depth of 2 inches. And right now it's just cleaning up that outside. So that is a flame cut on 3 sides and then a saw cut on that angle on the front there. I'm real happy with the way that end mill is cutting. You know, this stuff, obviously it makes me really nervous, but once you see it actually start running through the program and nothing crashing. I am having problems with those chips building up over there. You saw me originally, I was using the coolant nozzle here to kind of spray and wash the chips away. A little harder to get to the back though. I'm real happy with the setup. Our Heimer shrink fit tool holder doing a beautiful job. That Titan end mill is doing a beautiful job. And part of this is being able to come onto the program and make adjustments on our feeds, our RPMs, and just see if we can improve the speed in which we get this part cut. Need to see if I can get those chips off the back side there. Really trying to build up behind it. It's a lot of cut. This front side's a little bit easier. I've been taking this chip brush and just kind of trying to knock them out of the way. I think I spoke about this before. whenever we're doing our program, and we're using a feature in the software called Chip Boss. And once you give it the coordinates of what you're machining there, it figures out, it calculates its own tool path. My understanding, it's supposed to be optimized to work with the quickest tool path that it can for minimal cut time. So now it's working on this front angle section on this side, removing it after we've already squared up the rest of the plate there. I'm sure that radial infeed can be improved too. Right now we're cutting 25 thousandths radial infeed. I don't know what the cutter will handle, but that's part of my practice and just experience here, knowing what the cutters can actually handle. I wonder if it'll handle 50 thousandths. To me, that's kind of pushing it, but it may be able to handle it. Try to knock those chips out of the way. But it's doing pretty good. I've been working on this, and then I've got another fixture plate that I've been working on too. I paused on that because I wanted to make some modifications to our program, and I'll finish that once I get through playing with this piece right here. Cleanup cut at 100 inches a minute. Oh, it's doing good. Two inches. All right. Let me make sure we, okay, yeah. That's why I like having the optional stop set so that I can kind of regroup in between the cuts there. So I'm real happy with that finish pass. We had that set at 100 inches a minute. I forgot we had it set that fast, but it really did go around it quickly. I don't have the coolant on. That worked out pretty good. Nice. So now we got the Walter face mill in there, and we're just going to take about 40 thousandths off the top to clean that. There was some weld on the top of that I ground off, but hopefully that'll clean it up pretty good. Just went ahead and set you in the machine because I haven't proven this part of the program out, but we're going to go ahead and face the top of that block. Them sparks ain't good. I might have already got those. I might have burned up the tip of those inserts. Forgot I'm making 2 cuts on that. I'll have to check those inserts. Oh, you know what? I wasn't even running the right speed because I kicked the rapid down to 50% on that, and I forgot. I got a little edge on it right there. I think I might have messed up the inserts on that, so I'll have to pull that tool and check it because the tips are probably burned up. This should be our chamfer here. I'll run it in slow, make sure it doesn't crash. Going up to 8,000 RPM before it moves. Looks right. That should be it. I got to thinking on that face mill. I believe what happened is yesterday when I was cleaning, or I'm sorry, when I was machining this fixture plate here, I had set the Z to 0. And when it came across here and started cutting this plate for the first 2 passes, all it was doing was cutting mill scale. And I know that's not good on inserts because that mill scale is really hard stuff. I believe when I made these passes on that mill scale, it might have wiped the inserts at that point, because I made the adjustment to clean that up and then finished cutting it, and I thought the finish was going to be nicer than that right there. So I believe we already started with bad inserts when we came over here and did this, but there was that weld up there, which isn't good. It could have been hard up there, and we were cutting through the mill scale on the top of that. So now that we got all that junk off there, I'm gonna index all these inserts and then adjust the depth and make another pass and see if it does better than what it did there, because you can actually feel a little tiny rolled edge there. So I think it's rubbing. I think it's pushing on the material instead of shearing it off there. I'm gonna get these chips cleaned up and index that cutter and then make another face cut on that block. All right, so I've got all of my inserts there indexed around. They were burned up there, so I'm almost positive I burned it up on that mill scale and out of the plate there. So they were already bad when I did that. Plus I only had our rapids at 50%, so it wasn't running the speed at which I actually had the cutter set at. So I've gone into coordinates on the machine, G92, and our Z, I've dropped at -40 thousandths. So we're gonna go back in there, we'll just start the program with the face mill, and that way the face mill and the chamfer will be lowered 40 thousandths and just make that same cut that we just did. It's looking a lot better, like it's supposed to. Yep, that was the trick right there. Now that was a real fast feed rate. We had that set for our Walter mill set at 96.7 inches a minute. Going off recommendations from Walter's website there for that particular insert for that face mill. I think there's room for improvement if you're trying to make a part with a really nice smooth finish. Maybe slow the feed rate down a little bit where you're not going so aggressive, because that one's set at 8 thousandths per tooth. But that did the trick, so I'll make sure I go back in there to our coordinates and set our Z back to 0. But that looks pretty good. I'll continue on practicing with this piece. What I'll probably do is we'll take it out of the Adaptix vise there, and we may just use our hard jaws over on the other vise there and set up a. We'll probably probe the fixed jaw on the back as our Y, and maybe on the side of the jaw there on the end as our X0, and then finish out the top to kind of match it there. But I'm going to come back later and finish that out.